What do woodpeckers and football players have in common? Their colorful uniforms? Their inclination to defend their territory? Well, yes, but more importantly, they both have to do with shock waves to their brains. When a woodpecker makes a hole in the side of a tree for a nest, they slam their beak into the bark 20 times per second, thousands of times per day. The force this puts on their heads is upwards of 1,200 Gs, or 1,200 times the force of gravity. We humans can only handle about 80 to 160 Gs of force without sustaining traumatic brain injury, which can cause serious problems like headaches, loss of balance and coordination, impairment of concentration and memory, and even personality changes. Our brains make us who we are, and we need to protect them from these shock waves. So how are the woodpeckers doing this without damaging their brains? And how can we learn from them? Researchers in the group of Professor Eliasson at the University of Southern California, Viterbi School of Engineering, are trying to answer this question. But how do you study forces on a woodpecker's head? You build your own. These researchers plan to build a model of a woodpecker skull using materials with the same density of a woodpecker's bones and tissues. By attaching it to a motorized arm, they can approximate the experience of a woodpecker chipping away at a tree trunk. With this, they can measure the shock waves the brain cavity of the bird is actually being exposed to. But that's just half the problem. We also need to know how much force a brain cell can handle without dying, and how the time between impacts affects the brain. For instance, are impacts 2 weeks apart worse than impacts 2 months apart? For this, the researchers partnered with neuroscientist Dr. Sengupta at Washington State University. They got a thin film of neuronal networks made of mouse brain cells and exposed them to various strengths of shock waves to see where the threshold lies for neural stress and damage. Better understanding how nature has built the woodpecker skull to protect its brain from shock waves can better inform our designs for helmets. With any luck, we can keep soldiers' and football players' brains as safe as a woodpecker's.